Hello everyone. In this video, we are going to discuss about one of the interesting release from NVIDIA, which is Nemotron 3.5 ASR. Nemotron 3.5 is an automatic speech recognition model with just 600 million parameters. The small model already supports 40 languages and can be adapted for both offline and streaming-based inference. The previous release from NVIDIA was Parakeet model, which had more than 1 billion parameters. The number of parameters in Nemotron 3.5 ASR is just 600 million, which is almost one half of it, and it also provides high throughput. Before we get to try this particular model with CPU and GPU based infrastructure, let's try to understand what is this cache-aware system which helps the model to provide high throughput. Let's try to understand this workflow in 6 simple steps. Start with a simple question. What is the difference between streaming ASR and offline ASR? In case of offline ASR, the model does not do any action when the person is speaking. The model patiently waits for the speaker to complete the entire sentence, and only after the full audio is available, model starts transcribing it. In case of offline ASR, model has all the context available to predict the appropriate words. However, streaming ASR doesn't work this way. In case of streaming mode, the audio inputs are sent in the form of chunks, and each chunk needs to be processed by model separate. The first chunk may have the word please, and second chunk may have the word right, and hence model has to run the predictions every 80 to 100 milliseconds. Okay, let's move to the second step. As we are receiving individual chunks, you might be thinking that we are receiving individual chunks, and why can't we process these chunks separately? It is not possible due to the nature of streaming data. In case of streaming data, there might be overlapping words. Let's take this sentence. Please write letters to all the students. If we have 3 chunks where the boundaries of these words are well within the chunks, as such, chunk 1 contains please write, chunk 2 contains letter 2, and chunk 3 contains all the students, then the transcription of the model will be accurate. However, due to the streaming mode, there could also be the case that chunk 1 contains please write, and the second chunk contains the remaining pronunciation of that particular word from the speaker. And hence, it is very important to note that the meaning of this particular chunk also depends on the chunk which has been received previously. Let's move to the step 3, and we will try to understand how traditional transformers work on streaming data. Let's imagine we are on step 2, where we have already transcribed the 2 words please. Now we are getting new audio chunk which has the word letters. In order to transcribe this particular chunk, the model needs to recompute the previous chunks which contains please write, and this exact chunk has already been passed in step 2. As the conversation grows, the number of computation grows rapidly, and it drastically increases the latency and GPU usage. This is not an ideal solution. There should be some smart way to solve this. That's exactly what NVIDIA's cache-aware fast conformer does. To give you a simple analogy, imagine that you are reading a book and you are in chapter number 2. In order to start a new chapter, you don't have to read the previous chapter all over again. Just based on your previous reading, which is there in your memory, you are able to process the current chapter. The cache-aware fast conformer works in the same way. When it receives a chunk, as soon as the chunk is processed, it caches the representation of the chunk. When the new chunk arrives, the model doesn't have to compute the representation for the previous chunks. Instead, it will reuse the representations from the cache. This drastically reduces the overall latency, and at the same time, the number of computations that needs to be done with the model is very low. Although the number of computations has been drastically reduced, the problem which we discussed in step 2 of overlapping words between multiple chunks hasn't been solved. That's why we have step number 5. Let's try to understand this with the same sentence. Please write letters to all the students. Imagine in the first chunk, model received the audio, please write, and model is performing the transcription of this particular audio. And in this particular case, due to linguistic complexity, model doesn't know whether to transcribe it as WRITE or RIGHT. The transcription of this particular word completely depends on the word which is going to occur in the near future. Hence, NVIDIA's fast conformer architecture uses this concept of look ahead. Instead of transcribing the chunk as soon as it is received, it makes more sense to wait for a smaller window, 80 millisecond or 100 millisecond, so that the model gets more context about what user is speaking. Imagine in the next second, the model received another chunk where the word letters is present, then it makes more sense for the model to predict the word WRITE as it is connected to the word letters. And hence this small lookup window is super useful to provide accurate transcriptions. Here we are at the final piece of the puzzle. which is decoder. NVIDIA's Nemotron 3.5 ASR has two decoders, CTC and RNNT. Each of these decoder does the job in a different way. CTC is more about fast. You can think of this particular decoder where it kind of finds all the words which occurred in the audio. It has very weaker language modeling, and that's why we have RNN. RNNT decoder has a better language understanding, and in order to decode each of the word, it considers previous words. At the end, RNNT provides better accuracy and good language model. The decoder segment of Nemotron 3.5 ASR combines the output of both of these decoders and provides much more accurate transcript for streaming data. In a nutshell, Nemotron 3.5 ASR has three magical steps. One is the cache-aware architecture, where it stores the representation of the previous inputs and reuses them when needed. Look ahead, which is a smaller window which helps for better predictions. And number three is the combined decoder, which provides better language modeling and predictions. Hope this content was interesting and useful to you. If so, hit the like button and subscribe to the channel. Thank you. See you soon in the next video.